Now, once again, as we go on to section 4 of chapter 8, applications involving quadratic equations, here we're only having 4 examples. If you go to the lesson on chapter 8, section 4, where I used a textbook, you're going to get a lot more background. This is just meant to be a little brief outline of the kinds of things you would do to be able to do your practice and quiz me. So, as we look at this, example 1, and we're going to be solving problems and solving formulas. Horace drove his car this many miles at a certain average speed. Now we know this is going to be our distance, and this is going to be our rate. Now let's just work with this for a moment. We notice the formula we're going to be using here is distance equals rate times time. So here we have the distance. We don't know the rate, but we're calling that R. Now here they're giving us some more information. It says if he averaged 20 miles more per hour, the trip would have taken 1 hour less. So we're kind of getting a feel for it. If he goes faster, it's going to take him less time. That makes sense. They want us to find Horace's average speed. We want to find out what R is. Now, we don't know his rate of speed, R, and we also don't know the time. So we're sort of introducing 2 things here. We don't know R, and we don't know T. Now, is there a way to eliminate one of the letters, like T? Is there a way to eliminate time? So we can only deal with, let's say, distance and rate. We'll have one variable. Well, if we solve this basic equation for time, we get time equals distance divided by rate. And if we knew what our time was, and we could equal the time, then we might have an equation that looks like this. Distance divided by rate equals distance divided by rate. Now, let me say that they do give me the answer for this, but they didn't give me the equation. So I had to sit down with a piece of paper, and if you look at my booklet, you'll see that I've written this out and thought about it. In fact, I even had scrap paper to try different things. Okay, so what we're going to do is put what we know into this formula. Distance divided by rate. We know this is time, and we know this is time. So 240, our distance, divided by rate. That's the first thing they're giving us. And we're saying somehow this is going to be equal. It's not equal yet, by the way. Right now it's not equal. Right now this is not equal. But we're setting it up. 240 divided by the rate plus 20 miles an hour faster per hour. Now, here's where we get to make it equal. We know that there's 1 hour less if he goes faster. So we're looking to make this an equation. Now, let's say this is 4 hours to do this. Then this would be 3 hours to do that. That is 1 hour less. So if this is 3 hours of time, what do we have to add to this side, because this is time, to make this equal to 4? This represents, let's say right now, 3. This is 3 hours. What do we need to do to this side to make it equal 4 hours? Well, the answer is we have to add 1 hour to this side, because this side already is 4 hours. This side only is 3 hours here. To make it 4 hours, we had to add to 1. Remember, this is time. This is distance divided by rate. That's time. And now we have our formula. And let's pause. So I cleaned it up here a little bit. And now I have my equation. I have a rational equation, or an equation with fractions. To get rid of my fractions, I have to multiply each term by my common denominator, which is r, and r plus 20, which I have up there. So I'm now going to generate an equation over here without fractions. So r will go into this r and cancel this out, and then I get this. 240r plus 20 times this is plus 4,800. I'm just multiplying. I canceled out the r, and now I'm multiplying r times this and 20 times this. Okay, and that's going to equal, now here the r plus 20 cancels out, and I'm just left with 240r, and then I have a 1 times this, so this becomes, I'm running out of room here a little bit, r squared plus 20r. Okay, we call this planning ahead, where you don't want to run out of room. Okay. Now, an interesting thing happens. When I want to get all of my terms on one side and equal this to a 0, this just subtracts right out here. And now I'm just going to put everything over on this side here. So this is r squared plus 20r, this. And now I'm going to transpose that, and that becomes a negative 480 equals 0. Now I did it that way so I got more room. I'm just moving everything over to this side and then moving it to that side. So r squared plus 20r is this. Now, what can we do to solve this equation? Well, we can use factoring. We can use completing the square, or we can use the quadratic formula. Now, interestingly, this actually factors. So I'm going to use factoring. Now, I didn't just note that. I studied this. I told you I worked this out on paper ahead of time, And I looked at that and I tried different techniques. So we want factors of this, because we know this is just going to be R and R, and one's going to be plus, and one will be minus to give you a negative term here, and there needs to be a difference of 20. Now, as you look at this 48 here, can you all see 6 times 8 there? Do you see that? 6 times 8 is 48. So let's try 80 times 60. Now notice this times this gives you that, and when you do your outers and inners you get a difference of positive 20. These are the factors. But let me, even though I'm making it look easy now, I studied this. I played around with it. Then I saw it. So R is going to equal negative 80. R is going to equal 60. Now, do you have a rate of traveling forward at negative 80? No. So we reject that one, and there is our answer. So his average speed right here is 60 miles per hour. And we spent 11 minutes on it. I spent 20 minutes on it because, I had to think of all of this. And again, there are more examples on the additional exercises and in the textbook. Again, I worked all of these out on paper. I have them in my booklet. And I just didn't go through it. I had to think of what did we want to do. Well, here we want to isolate our G. So I'm going to divide both sides by 2 pi. So I now have T over 2 pi equals L over G and the square root of that. Now again, I'm still looking for G here. So I want to get it out of the radical sign. I do so by squaring both sides. Now I have T squared over, I'm squaring that, I get 4 pi squared, and this equals L over G. Now, notice we have a fraction equaling a fraction. What tool did we say we could use in a case like that? Well, we can just cross multiply. So we have T squared G equals 4 pi squared L. And you might say, oh, we're really close. Yes, we are. Because now if we want G, all we do is divide by T squared. These cancel out, and there's my answer. And this is a T. There we go. So not too bad. And again, they don't show me how to do this. I had to do it. All right, let's look at B here. Now we want to solve for the letter T. Notice we have a T there and a T squared there. Oh. So we go into our toolbox and say, what can we use to solve a funny kind of quadratic equation for t? And the answer is the quadratic formula, which I will now put this in standard form. So this is going to be 16t squared plus VO, that's initial velocity of t, minus s equals 0. So what do we want to do if we want to use the quadratic formula? Take that little mark off of there. We want to identify what is a. Well, this is a, the numerical coefficient of t squared. What will b be? Well, it's a positive v sub o. And what is c? C will be a negative s. So there's our a, there's our b, and there's our c. Now again, I had to look at that, and I also took a peek at the answer too. That helped me. So now I'm going to go t equals negative b, so that's going to be a negative v sub o, initial velocity, plus or minus the square root of, what will b squared be? Well, we have to put this in parentheses, v sub o squared minus 4, which is in the formula, a, which is 16, and c, which is a negative s, all over 2a. Well, we can just put that there as 32. 2 times 16 is 32. So, cleaning this up just a little bit, we get negative initial volume, velocity, plus or minus this in parentheses, didn't make that V too well there. And then this is going to be a positive 48S all over 32. Wow. And I made a nicer initial velocity symbol there. And of course the answer is down below. But again, it didn't tell me how to do this, but when I took a peek at the answer and saw they were using the quadratic formula, that was the hint I needed. Okay. But again, you're going to get something like this, and you'll have to figure it out. But as you practice, keeping your homework log neat and orderly, a very good technique. This is how it's done, and you could always watch the video again. Okay, let's do this one here. I don't want to put any extra marks there. Here we go. Now, the main thing here, we're going to square both sides. So when we square both sides, we get w squared equals 1 over LC. And again, this is over 1. We can cross multiply. So we get w squared LC equals 1. And we want to solve for C. So we're going to divide out those things we don't want as factors on the other side. These cancel out, and we get C equals 1 over W squared L. So that one was sort of an easy one. Okay, Well, we kept it to just under 20 minutes.